Burton from Continuum, who's going to talk about string diagrams with wiggle.py.
Hi, everyone. So I basically want to see more string diagrams in mathematics because I can't understand algebra pretty much. But I found string diagrams really helpful. So this is some experiments that I've been doing with Python which I'm going to show you. So I thought I'd just start off by talking a bit about higher category theory, and probably everyone knows this stuff better than I do, but I'll also show pictures that wiggle.py makes of string diagrams as we go. And I'm going to skip all the technical stuff about associativity and that the experts know about. Okay. And then if I'm sufficiently excited, I'll do a demo and then show some, talk a bit about the implementation of wiggle.py. So, right, so monoids are our basic storytelling device that we have an F, and you won't believe what happens next, G. So, yeah, so arrows are great, but string diagrams I think are amazing as well. I'm not quite sure why they seem so much better than arrows, but maybe it's like a homology, cohomology thing. But anyway, if people have thoughts about this, I'd be like to know. But yeah, so that's a wiggle.py string diagram. And categories are like multicolored strings here, or multi-object monoids. And then we want to compose in another direction here our string diagrams. So these are diagrams in monoidal categories. And then the space in between the strings can be colored, and so these are bicategories now. This is like the fastest introduction to higher category theory ever. Okay. And now this is like another direction here, and so this is a monoidal, this is a picture in a monoidal bicategory. And you can see I'm kind of running out of colors here. I don't really know what the semantic of color is. I think like the gray means anonymous and the color means like a letter. So L is like, I guess that's the string that underneath F here, something like that. So yeah, now interesting things happen when your strings and when the pieces of your string diagrams are allowed to live in a higher dimensional ambient space. So you can start talking about community of monoids. So your F and your story elements are kind of allowed to reorder themselves like particles in a box. And then this in higher dimensions, you can think about strings that are allowed to pass through each other. So this is like, these are really, morally, these are four-dimensional string diagrams. So strings in 4 dimensions can, they don't not. So, and so here's a picture of an equivalence between 2 objects. This is saying that we have isomorphisms between these 2 objects, and these isomorphisms are not on the nose inverses of each other. We actually talk about how the isomorphisms are inverses of each other. So this is like a bubble popping equation. And then this equation here, what should we call it? Does anyone have any idea what to call this? That's bubble popping. What's this? Pass through? Yeah, okay.
Amoeba sex.
Amoeba sex. Great, Ross.
Better than my
And if you're familiar with Christopher Nolan, the great storyteller, this is a story device that he uses quite effectively called adjointness. And right, so these are some pictures from a braided monoidal category. And here the idea is that these are surfaces in 4 dimensions that potentially could be knotted now. And the idea is that this data here form an adjoint equivalence. So these are the equivalence equations. So that's the bubble popping equation, and that's the amoeba equation. And this is the one of the snake equations for the adjoint condition. And looking at these equations, you really start to believe that, yeah, these surfaces, these really are surfaces in 4 dimensions. This is really what we're talking about. But if you look at the literature and you'll see a bunch of arrows, and your eyes will just fall out. So, but
What is it 4 dimensional? Why do you keep saying 4 dimensional?
is it not?
It looks 3 dimensional.
Right, but right. So I guess this is a projection of a 4-dimensional. All of the diagrams are being rendered in a 3-dimensional coordinate system, but
What is 4 dimensional? Do you mean like the equations somehow bear out as 4 dimensional?
yeah. So you think of how should I say this? Yeah. So these are surfaces in 4 dimensions. The algebra of a monoidal bicategory, of a braided monoidal bicategory, they're describing surfaces in 4 dimensions, something like that. Modulo a bunch of stuff I don't want to talk about. All right. And that's the other guy.
Oh, sorry, I need to clarify, I mean, like, if you say braided
Please.
monoidal 2 category, then you actually have a sort of twice degenerate, 4-dimensional category. That's how you get braiding.
Yep. 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 Okay, so how's my time? Right.
You've used 7 minutes of your 30.
Okay. Okay, so I'm feeling ambitious, so I'm going to try a demo here, but I've run out of hands. I don't know, maybe I can do that. All right.
But actually, I didn't use the mic because I was just standing in front
Oh.
of
The lectern mic should also work.
Okay.
But you have a very steady head, otherwise you'll have very wide volume oscillations.
Okay. So there's some boilerplate code up there, and I'm going to just make this. If this fails to work, I'm just going to switch back to the slides here. Totally, I've even forgotten how this works.
Maybe there's a U missing in the corner.
British English.
Okay, yay. All right. So let me give that a name. And then I can take a monoidal product here, evaluate this guy. And so let me try and make a Frobeniator. So I'm going to need 1 cell. And let me give this a name. And then we need one going the other way. And I'll give that a helpful name as well. Okay. So then the horizontal composition. Oh, it's there. And there's the other guy. Well, this is just going to be a kind of a bubble, I guess. So that's not what I want for the Frobeniator. I want something a bit more tricky. What is this? You can kind of so that was a monoidal product, and I'm going to horizontally compose this now. How is this going to work? All right, and so this, I'm going to give a name. Maybe that's my source. And this one can be my target. And I tend to do things in that order, but there it is. Okay. Okay. Oops. All right, so that, yeah. There's also, I have a bit of code here for just people like to put letters here. I don't like this, but sometimes you have to put letters on the string diagrams. Okay. And yeah, you can compose these. The whole thing is supposed to be composable. So the implementation of this, it's getting too big that I don't want to chuck it out and rewrite it again. But this is a drawing package called Huygens that I've been working on and using myself for a few years, based on another Python package called PYX, which is really great. And I just got annoyed at PYX because it was really tied to LaTeX, and I wanted to use ZLaTeX and some other different fonts in my stuff. So this module POV, it's like a OpenGL implementation. It does all the projective matrix stuff. It pretty much is the basic OpenGL implementation with the vector graphics output. And the whole thing is based on chirographics, which outputs in those formats. I'll just go over some stuff about the code. I mainly was interested in finding something reasonable that I could type, and I just was showing you how that stuff works. And one thing that got me when I was building this was you want the system to lay out the objects. So this thing, once you've composed this thing to make a monoidal product, you're reusing the object here. So if you want to start storing the coordinates and other attributes on these objects, you're going to somewhere you're going to need to clone everything. So maybe, yeah. That was like a major breakthrough when I worked that out. Okay, and the whole thing is based on, the layout is based on linear programming, and so you can add in a lot of your own constraints. So like the default pair of pants will come out looking like this. And if you want the output of the pair of pants to be the same width as the input, you can do that by adding linear constraints it's like a callback that you define. And I think the way that this is going is that there's just ends up being a lot of parameters. So, but that's okay, because every little piece here is another object, and as you're building it, you can describe how all those little pieces have the line, the color of the line, or the color, the pip, or is there LaTeX there, or whatever. Okay. Right, I already mentioned that it's all vector 3D stuff, and I think this alpha blending is the way to go. I had noticed that the homotopy.io people are not doing this. I think they really are doing raster stuff. I'm not sure, but does anyone know about this? Like all the surfaces are triangulated, and is that how that works?
I have worked on homotopy, not on the
graphics.
render, so I cannot say.
Okay, but anyway,
I really like this graphic.
Yeah. So the alpha blending is really great for seeing this stuff, and I haven't seen that in homotopy.ios, but so maybe they can. So that's transparency. Yeah. And
a bunch of debug options for tweaking the graphics render.
Yeah.
Maybe some combination of those.
Yeah.
Can achieve that.
Yeah. Okay. Right, and this all works by just ordering from back to the front and outputting vector graphics commands. And the the core algorithm. So this is a funky looking 2-cell. All it's doing is decomposing this into curvy triangles. So it's just like looking at all the 1 cells and the inputs and outputs and breaking this up into little triangles. And then there's a fan for over here. So yeah.
Excuse me? Is there a way to grab a 3D thing like this with my mouse and turn it around to see it from different sides? To have a, you know, like in MATLAB you can do this with 3D. Right?
That's a good. So someone was asking if you can actually drag this around and see it from different perspectives. Well, first of all, the code is very slow, so you would probably get maybe 1 frame a second or something like that. But I mean, you can look at this from other points of view or from the back. But look, there's an important trick here that I haven't really pointed out, is that this is pseudo 3D. Like, these are all flat surfaces here. So as soon as you change the perspective enough, you're going to lose. So you can't. Yeah, it's really the boundary. Yep, yeah. So this, all right. This is a piece of the Samologikov tetrahedral equation. It's like, imagine this is a 10-story building. That's 2 of the stories, and it equals some other 10-story building. And I kind of got lost and panicked at the same time, and that's as far as I got. But this is already about 1,000 variables that it's using in constraint satisfaction to build this guy. And the data structures here are fairly straightforward. It's this depth, the monoidal, horizontal, and vertical composition. So it's basically lists of lists, on and on. So yeah.
And so you mentioned that the code is pretty slow. So how long did it take to generate this?
That's about 5 seconds, or 5 or 7 seconds. It's not too bad. I mean, the constraint solver is SYPy linear constraint library. Yeah. I think the API is pretty stable. I've actually written a lot of stuff using this, so I'm not keen to change the API at all. There could always be more documentation, and I don't know if this is an invitation for you guys to use this or make your own. Like, either way, I'm fine. Like, if you want to use this stuff, please let me know, and I will be interested to help you. Or and there, yeah. So I think this basic structure is right. It's gone through a few complete rewrites, and I'm happy that even if the guts needs to be rewritten, that the API is good. So, and there could be, I didn't write this, but there needs to be better error messages as well. So, all right, that's it.
We have time for questions. I'll ask the first one. How do we get it?
It's right. So it's on GitHub. This is a good question. Yep. So there's a line of pip install GitHub blah blah. I'm sorry, I don't have it. Yep.
Two questions. One is what's the workflow to put this in a later paper?
Right. So it's.
I will use this as my thing that I generate diagrams for a paper. Like, how would you do? We just first generate PDFs.
Yeah, you make a little PDF. That's it.
And then a quick PDF.
Yep.
And my second question is, can you imagine doing animations with it?
Yes, I have.
Okay, so
Yes.
This functionality already exists.
Well, if you can output images, you can just output a lot of them and then bang them in an animation. So you may be talking about something more interactive, or.
No. I mean, so like, because you kept them going like four dimensions.
Oh yeah. Okay.
I want to have
Right.
an equation between 2 3-dimensional diagrams.
Yeah.
And I say, instead of visualizing it as this, it's a string diagram.
Yeah.
As an animation.
Yeah, so that sounds great. Yeah, I haven't tried that. That sounds exciting. Yeah, I I see. I don't think there's any fundamental reason why that shouldn't work. But I will say that the constraint satisfaction stuff is pretty tricky to get right. It yeah.
So make matters first.
I was just going to say, so you said that the potential issue with doing this sort of interactive diagram idea is that it takes a long time to generate the images. But I was thinking like where is, if that time is maybe in the constraint satisfaction, and that then generates like a model, then surely like with modern computers, like actual taking
Yeah.
model and turning it into a projection that you see on your screen.
Yeah, that should be. You're right. I mean, there's the layout step could be just done up front, and then you just move the perspective around. So that should, I mean, 10 frames a second. Yeah. That's reasonable. Yeah.
Alex? I guess this is a similar question. Did you say at some point before that this isn't actually generating a 3D model, it's just generating sort of...
Well, it's just that these, how do I describe this? Like, there's no, like a real 3D stuff, like these surfaces get triangulated and then there's a lighting model applied, ray tracing, blah, blah, blah. But yeah, there are 3D, it's a 3D layout engine. That's right, yeah.
Can I ask you instead about the more logical side of the library, whether like it comes with a tag tracker that will reject like unsound compositions?
Yeah. Right. So that, I guess that's when you start building these guys, that's this M here. So as you're building bigger terms, it uses this string to do the type checking. So yeah, so this will have some type. It's going to look like that pretty much. So if there's a vertical composition going on here, the type at the top here, which is this, will need to match, right? But if you, yeah, am I getting, is that a, yeah, yeah. I mean, I'm more interested in seeing this stuff than doing something that's technically correct. So yeah, yeah.
No more? Okay, well, thanks very much, Simon.